Saxon's Calculus, Lesson 45 is about explicit differentiation. So they remind you at the beginning of the lesson that implicit means when I have x's and y's embedded on just together within a problem. In their particular example, you have an xy plus 1 equals 2x minus y. So you've got x's and y's on both sides. In the explicit one, y has been isolated and only x's are together on the other side. So how does this affect when we are deriving? So let's look at example 1. They give us xy plus 1 equals 2x minus y, and we are asked to derive and find dy over dx. So what I notice is that I've got embedded x's and y's all together, and as I derive these things, I'm going to have to attach the dx or the dy and then rearrange them algebraically to solve for it in dy over dx. So let's do that. Ultimately, this is where I'm headed, so I'm going to have to work over here. Since these two are multiplying, I need to follow 1d2 plus 2d1. So 1 is the x, derivative of y goes to, the 1 comes down and makes 1y, but then 1 minus 1 is 0. Y to the 0 is 1, so I'm multiplying it with a 1. But because I was deriving there, that's a dy. Then 1d2 plus 2, so the second one is y. Now we're deriving the x, which has the same problem going to 1, but because I was deriving dx, I put that with it. I was deriving the x, I put the dx there. Equals, plus, the 1 is a constant. It's going to drop off, which is why I instinctively went to the equals. And then the derivative of 2x is 2. And because that was with an x, we attach the dx minus, and then the y goes to 1. But this 1 has to have the dy with it. Now we rearrange and put our dy's on one side and our dx's on the other, and then we'll do the ultimate divide. So this is a dy with an x, and I'm going to go ahead and factor out dy kind of at the same time as I do this. So this one had a dx, I'm going to move it to the other side. This had a dy, so I'm going to put plus 1 over here. And again, I'd already separated out the dy. So now I'm going to do the same thing with the dx for this side. So I'm moving this one, making it minus x, and this one was already plus 2. And now I'm going to go ahead and write my answer over here. So dy means this stuff goes underneath over here. So negative x plus 2 is numerator. X plus 1 is in the denominator now from dividing it, and then dy is here, and then dx is dividing to the other side. So now I have solved it for what they asked, dy over dx. Just a second, in their answer they have 2 minus y. Did I miswrite a letter? Most certainly did. I caught my mistake. Here when I subtracted the dy statement, not the y, which was the dx. So that should have been y with the dx, moving over, making it the minus y when I moved it, and then the 2 was still there. So yes, this would have been minus y, and they just wrote it as 2 minus y over x plus 1, but same difference. Now, example 2. If y squared minus xy equals sine of x, and both x and y are functions of time. Okay, we've not seen this before, and I don't think I put my I in sine. We need to, when it says as a function of time, it's implying that every single piece each time, so here where I would have a dy, it's actually dy over dt. So it's the derivative of y over the derivative of time. So it's automatically put in there as we go. So in part A, they ask you to find dy over dx. So we're going to do it normal and not worry about the time on that one. So here, this is going to go to 2y dy minus, okay, this parenthesis here is going to have our 1d2 minus 2d1. So 1 is the x, derivative of y is gone, dy, 1d2 plus 2, which is your y, and the derivative of dx, or the derivative of x is going to change to dx, and then equals, and then sine goes to cosine of x dx. And we need to put our dy's on this side. So again, my 2y is going to be in a parenthesis, and our dy I'm factoring out. This one has the dy, so there's still a minus x here. This side doesn't have a dy, so there's nothing moving. And then equals, and we're going to have our cosine of x in the parenthesis with our dx outside. And this was a negative y dx. So when I moved it over, it became plus y with the dx on the other side. Now, this stuff will go underneath, so I'm going to change that to y plus cosine of x just because I prefer it. And then 2y minus x is underneath. There's our dy. Our dx has divided over here to this side. Now let me check their answer. So cosine, oh, they flipped it. Cosine x plus y, 2y minus x. There is our derivative for A. Now we're obviously going to have to get more space to do part B, which asks for dx over dy. Now that is the exact opposite of what I just had here. So it would be the flip-flopped of things. So I should have the 2y minus x on the top and the y plus cosine of x on the bottom. So I'm just going to write that over here. But that's really all you're doing there to get it in the flip-flopped format, cosine x plus y. Now the last one, C, asked for find dy over dt. So we needed to solve for the dy. To get it solved for the dy over dt, I need to take it back to the step where we had 2y minus the x was sitting with the dy, and then we had on the other side the y plus cosine of x was sitting with the dx. So what I told you before was that where we have the dy and the dx, we have to attach it with this over dt. So that's what we're doing here. We're automatically putting it over the dt. So this is the piece that I need to solve for by dividing this piece underneath. So my dy over dt will be the y plus cosine of x over top of the 2y minus x, because they already had embedded the over dt. Example 3. If x squared y minus y e to the x equals cosine of x, find dy over dx. So we're going to derive, this is multiplying, so we follow our song. 1, derivative of y goes away, but dy, 1d2 plus 2, so y, and then the derivative of this one is 2x dx minus, here I have another multiply, so I'm going to follow the song again. 1, which is y, derivative of e to the x is e to the x dx, 1d2 plus 2, that's e to the x, derivative of y goes away, but that's dy, equals derivative of cosine goes to negative sine dx. Now we need to put all our dy's together. I'm not going to factor this one as I do it because it's so long. So we have x squared dy, dx, plus e to the x dy, and that's a dx, equals This one's moving over. Minus 2yx dx. This one's moving over. Plus y e to the x dx. That one we already used. And this was already there. Minus sine of x dx. Okay, now I can separate these so that we have x squared plus e to the x dy equals negative 2yx plus y e to the x minus sine of x, all of that with the dx. Okay, so now you're ready to put it in this format. So this stuff is going underneath all of this. So we've got our minus 2yx plus y e to the x minus sine of x all over x squared plus e to the x. And there was our dx moved over. Now let me check that. Negative sine minus the 2. So they have the order rearranged, but that's okay. We have all the parts. Uh-oh. Except I have a sign dorked right here. Make sure I didn't have a sign negative. Negative. Wait a minute. Negative 2xy. No, that's it. Negative 2xy. Positive. Found it. This was a minus in front of this, so I should have had a parenthesis around all of this negating it so that when I move things around, I had it with this one, but I didn't have it with this minus e to the x. So this should have carried through the problem everywhere here, making this the negative, and then, oh, here. That one should have been the minus, then this should have been the minus. And now when you divided, you have it with the minus. Again, you got to be careful with all those positives and negatives. They'll get you every time. All right, then example 4. Find the slope of the tangent of the graph x squared plus y squared equals 2 at 1, 1. Find the slope. So finding the slope means deriving. So we are going to derive, thankfully this one isn't the song, so 2x dx plus 2y dy equals, and when I derive 2, I get a 0. And then we do need to solve for the dy over dx, so that's going to be moving this one over. So 2y dy equals negative 2x dx. Divide this by the 2y, and then divide your dx over here. So dy over dx equals, and then that reduces, so dy over dx equals negative x over y when I simplify it. Then we plug in the 1, 1, so that's negative 1 over 1. So negative 1 is our answer, and that would be the slope. All right, example 5. If x and y are both functions of time, and x squared plus y squared equals 2, same formula, find in A dx over dt. We need to go back to this one where it equaled 0, and on each of these then, so 2x dx over the dt plus 2y dy over the dt equals the 0. And then we're solving for, in this first one, dx over dt. So we're going to 2x dx over dt equals negative 2y dy over dt. And then we're solving for this. So we're going to divide by 2x. That is it solved, but we do need to reduce that. So dx over dt equals negative y over x dy over dt. Negative y, yep, okay. Part B asks for dx over dt, what I just did, at 1, 1. So plug that in. So for part B, that's negative 1 over 1, so that's negative 1 again. I was looking for their answer. Just a second. Oh, sorry, I didn't finish reading B. Hold that thought. B, find dx over dt at 1, 1 when this dy dt is 7. So this -1 is multiplying by 7, making that whole overall answer -7. Helps when you read the entire problem.